We are continuing with systems of equations. The first couple are kind of review problems, and then we'll get into a couple of them that are a little bit new. This first one, we were given 5x minus 6y equals negative 32, and 3x plus 6y equals 48. Often it'll say solve by elimination. It's pretty clear that you should use elimination in that case. We can tell that the elimination is going to be the best method here because none of the equations say x equals or y equals. All the x's and y's are on the same side of the equal sign. So we want to add the two equations together, and when we add the two equations together, we want one of the variables to eliminate. So the way it's set up right now, 5x and 3x, that is not going to eliminate. Negative 6y and plus 6y will. So it is set up for us nice here. We don't need to do anything prior to adding the equations together. So I can go ahead, add my equations together. 5x plus 3x gives me 8x. Negative 6y plus 6y cancels out. Negative 32 plus 48 gives us 16. 8x equals 16, so we should be able to solve for x. Divide both sides by 8, and we get x equals 2. Don't forget, a system of equations has both an x and a y. We need to solve for both variables. We now go back to either one of the original equations. I'm going to go to the top one, and we replace the x with 2. X is equal to 2, so I have 5 times 2 minus 6y equals negative 32. 5 times 2 is 10. Subtract 10 from both sides. Negative 32 minus 10 is negative 42. And divide both sides by negative 6. X equals 2, y equals 7. Example 2 looks similar. We have two equations put together here. Again, none of them say x equals or y equals, so we're solving by elimination. We're given 2x plus 3y is 11, and 2x plus 9y equals 1. Two x plus 3y is 11, 2x plus 9y equals 1. Remember, we want to add the equations together. 2x plus 2x does not cancel out. Technically, you are allowed to subtract the equations. I think it's easiest if we always add. So I am always going to add here. 2x plus 2x does not cancel. 3y plus 9y does not cancel. So when that's the case, we would need to multiply one or both of the equations by things so that it is set up like the first example and will cancel out. So if this were 2x and minus 2x, now it would cancel. So I need this to be a negative 2. I can make this a negative 2 by multiplying this bottom equation by negative 1. So we're going to multiply the bottom equation by negative 1 so that the top equation stays the same, recopy it. And the bottom equation, I'm going to do 2x times negative 1. 9y times negative 1, and 1 times negative 1. We are distributing that times negative 1. And now 2x plus negative 2x, those cancel. 3y minus 9y is negative 6y. (11 minus 1 gives us 10. And then we divide both sides by negative 6. 10 divided by negative 6. That doesn't come out even. That's no good. Not ideal. But we can write our answer in lowest terms. We're going to divide the top and the bottom by 2. 5 over negative 3. Just like example 1, we need to go back to the original problem and plug that in for any of our y's. So I'm going to use the top equation. It says 2x plus 3y equals 11. But instead of y is equal to 5 divided by negative 3. We need 3 times negative 5/3. 3 times 5 over negative 3. To multiply fractions, we just multiply straight across. 3 times 5, 1 times negative 3, 15 divided by negative 3 is negative 5. So multiplying these gave me negative 5. And finish solving. Add 5 to both sides. Divide both sides by 2. X equals 8, y equals negative 5/3. Example 3. Example 3, 2x plus 5y is negative 22. 10x plus 3y is positive 22. Two x, 10x, those don't cancel. 5y, 3y, those don't cancel. These cancel, but that's not one of the variables. We need to cancel one of the variables. Eliminate one of the variables. So we need to either choose the x or the y to eliminate, and we need to make them both the same thing, but one positive and one negative. So 5 and 3, 3 times what is 5? There's no integer that I can multiply 3 by to get 5. But if I look at the x's, 2 and 10, 2 times what is 10? 2 times 5 is 10. I can make this a 10, and remember we want it to be a negative 10 by multiplying by what? 2 times what gives me negative 10? Should be negative 5. We want to multiply the top equation by negative 5. And again, we figure that out by thinking through, this is positive 10, this needs to be negative 10. If this is going to be negative 10, I need to multiply it times negative 5. So I need to multiply everything in this top equation by negative 5. 2 times negative 5. 5y times negative 5. Negative 22 times negative 5. Negative times negative is positive. 22 times 5, this one would probably be a calculator problem, gives me 110. Bottom equation, we did not change. 10x plus 3y equals 22. Now we add the equations together. Negative 10x plus 10x. There's our elimination. That's what we wanted. Negative 25y plus 3y. It's negative 22y. And 110 plus 22 gives me 132. Divide both sides by negative 22, and we should have our y value. Get y equals negative 6. Now we want to go back to either equation. Doesn't matter which one. Generally, you want to choose the one with smaller numbers. That one's got a 10 in it, so I'm going to go with the top one. Plug in negative 6 for your y. 2x plus 5 times negative 6 in for the y equals negative 22. Positive times negative, 5 times 6. And we're down to a two-step equation. Add 30 and divide both sides by 2. X equals 4, y equals negative 6. Let's try another one here. 4x plus 2y is 14. 7x minus 3y is negative 8. In this case, 4 times what is 7? There's no integer. 2 times what is 3? There's no integer. So I am not only going to multiply one equation. We need to make them the same, but I can do that by multiplying both equations. So choose the x's or the y's. I think the y's, 2 and 3, are going to be easier to make the same thing than 4 and 7. And you want to think about, what can I make both of those? Well, 2 and 3 have a least common multiple of 6. I can make them both 6. I want this one to be 6. 6y. So I need to multiply 2 times what to get 6? 2 times 3. And if this one's 6y, this one needs to be negative 6y. So I need to multiply this bottom equation by 2. Distribute 4x times 3, 2y times 3 equals 14 times 3. Distribute on the bottom. 7x times 2, negative 3y times 2, negative 8 times 2. Six y minus 6y cancels. We add these together, giving us 26x. 42 minus 16 is 26. Divide both sides by 26, and we get x equals 1. We have our x, we need our y as well. Plug in 1 right here. 4 times 1 plus 2y equals 14. 4 times 1 is 4. Subtract 4 from both sides. And divide both sides by 2. X equals 1, y equals 5. Another one similar to the one we just did. 4x plus 3y equals negative 22. 6x plus 5y is negative 32. Four and 6, 3 and 5, we want to make them either the x's or the y's the same thing. I think maybe the x's might be easier, although the y's wouldn't be too bad either. Choose one to eliminate. I'm going to eliminate the x's. 4 and 6. 4 times 6 is 24, so I could make them both 24. There's actually a smaller one we could make them both. 4 and 6, the least common multiple is 12. So we're going to make the top one positive 12 and the bottom one negative 12. You could have done 3 and 5 and made them both 15 also. So I want this to be 12x. I can make that 12 by multiplying by what? Multiply by 3. 4 times 3 is 12. So that's 12x plus 9y equals negative 66. This one needs to be, well, that one's 12x. This one I want to be minus 12x. If I need that to be minus 12x, I need to multiply times negative 2. 6x times negative 2, that's negative 12x. 5y times negative 2 is minus 10y. Negative times negative is positive 64. Add your equations together. Gives me negative 1y equals negative 2. Divide by negative 1. Plug in 2 for your y. Plug it in right there. Would give me 4x plus 3 times 2 equals negative 22. 3 times 2 is 6. Subtract 6. And divide both sides by 4. X equals negative 7. Couple more basic problems I want to take a quick look at because they do turn out a little bit different. Notice this one here, this first one, 2x minus 4y is 6. Negative 2x plus 4y is 4. Sometimes when we solve by elimination, 2x minus 2x, those eliminate already. Negative 4y plus 4y, those also eliminate. Equals 6 plus 4 is 10. Everything canceled on this side. It means on this side I have 0. 0 equals 10. Well, it doesn't. 0 is never equal to 10. No matter what x and y are, 0 is not equal to 10. There is no solution. Let's try number 2. 3x minus 6x. Don't cancel. 4y minus 8y, don't cancel. If this is minus 6x, I want this to be positive 6x. I'm going to multiply this top one by 2. 3x times 2. 4y times 2. 20 times 2. Bottom equation stays the same. Add the equations together. 6x minus 6x cancels. 8y minus 8y cancels. On this side, I've got 0. 20 minus 20, that's 0. Well, 0 is equal to 0. When that's the case, like we've seen before, this is when we have infinitely many solutions. If you were to graph these, the first one, number 1 there, those would be parallel lines. They would not cross. The second one here, if we graph them, the two lines would be right on top of each other, which is when we have infinitely many solutions.